Is it going well?
Yes,
Mm, okay, recording has started. Hey, I forgot about I didn't check modules, but we'll see because that's not too hard. Yeah, we did talk about record structures. So the only thing we need to talk about is file handling. So what I would do is I'm going to open draw.io and then create a new diagram. I'm gonna call it files. And then yeah. So with file handling, right? What's the whole point of file handling? If you notice something when you're running our application, right? Whether it's a preg or whatever, every time we have to test it out, I get it, we have to enter the information again because
mm,
the information doesn't get saved.
mm.
So sometimes that's convenient. That's good if the amount of input is not that much. That's
We are
fine.
recording, right?
Yeah, I'm recording.
Okay.
Yeah, so it's fine if the amount of information we're getting from the user is not that much. Then we
Mm,
can keep on repeating that process, meaning every time we run the application, we get input again. But then
mm,
sometimes you might have a lot of input, like a lot. Let's say, for example, for us, right? Let's say you're making a game. It has
mm,
20 rows and 20 columns.
mm.
That's I think it's how many symbols would that be? I think it'll be 20 by 20, if I'm not mistaken.
Yeah.
The number of symbols that are there in the game. So
Mm,
imagine entering that number, which is should be 400, right? So imagine entering that number of values, 400 values on the input.
mm.
That's a lot.
Yeah.
And you're bound to make a mistake somewhere.
Yeah.
So we have a convenient way which is file handling. So file handling is literally file handling. Like when you go to File Explorer and you right click and you say create a new text document, right? A new file. That's
Mm,
literally what we are doing. But we are telling the computer to do that work for us. So it creates the file for us and it prints or it writes into the file on our behalf using code. It's a very advanced way of file handling, but it's actually very good. It's convenient because what we can do is we can tell Visual Basic that we want to create a specific file and give it a name. In this case, let's say it's called question5.txt, right? So we can tell Visual Basic create this file on my operating system using code, which would be equivalent to me if I was doing it manually. It's equivalent to me going to File Explorer, right-clicking, and creating a new text document. Obviously, it begins as empty. So after creating the file, we write code that writes into the file. For example, we write hello world, something like this. And
mm.
then we tell Visual Basic to print this text into the file, and we can save the changes. So it's literally like going here and you click save, but you do it using code.
Mm.
That's a bit advanced part of it. You use code. So you don't do this manually, you tell the computer to do it for you on your behalf. That's file handling.
Okay.
Or for example, remember the game I was talking about. You can instead just store the numbers here, right? Like this, multiple lines, store all the numbers you need. Then you simply
Mm.
read the file. So you see, you don't enter any input on the console. You
Yeah.
get the input from the file. So the file can serve as two things, as a way of us to get input, or as a place where we can print something, output. So the file can work in both ways. Which is true because for example, if I have a file like this and it's written hello world, right?
Mm.
And then I save it. When I right click this file right inside of my operating system and I say open, that's me telling the operating system to open it because I want to see the output. I want to see what's there. So it'll open the file. We're using whatever software you're using. Then you can read, right? So this would be the output. Or you can extract that information from the file as input to your application. So we will use it in any way, right? Could be both ways or none. So let's understand the process of doing that inside Visual Basic. So in order to understand files, we need to start from something that we call a file stream, right? So what is a file stream? So the way file handling works, right, is let me make an illustration. You have your file over here, which is that text file, right? So in this case, it's q5.txt, right? So let's say this is that file.
Yeah.
So you have this file, and then you have on the other side, you have the application, which is the Visual Basic application, right? So this would be Visual Basic application, right? So this is Visual Basic application, right? So there it is. So we want Visual Basic application to read from the file, but we can't do that directly. We do that through what we call like it's like a channel, right? It's like we can view that like me. I like to view it in this way, but in the
Mm.
slides it explains it. It's still fine or the way it explains it in the slides, but I like to view it in this way. I like to view it like a pipe, just like a pipe for water. I agree. We use that to transport water, right, from
Yeah.
one place to another. In this case, we call this pipe the file stream. So this is how we achieve this thing of reading and writing to a file. We do that through the file stream. So let's say this is your file, right? Let's say the file has hello world, and on a new line it has the number of columns and number of rows, and then it has a sentence. I am right. So that's the file. It is just made up of random things, right? So I'm just gonna put the name on the top. So this file is called q5.txt. So there's the file. So we can use what we call a file stream to transport the information to and from the Visual Basic application. So what this literally does, it does this. It literally, let me put it down here. It depends on what order you're reading and things like that, but most of the time it's like this. I want you to read it in this way. Let's say we read the string first, then that string hello world, it travels through this pipe, the file stream, and it gets stored in our Visual Basic application. And remember, this is what I call data. So we store it in a variable, right? So we're gonna need to create variables to store the information that we read from the file. Then once it's inside the application, that's up to us whether we want to print it to the console so that you confirm whether you did succeed in reading the file or not. Or we can just use that information for calculating an average or something. It just depends on what application you're dealing with. So this is one way to view the file handling. So it starts from the file, travels through the file stream to the file Visual Basic application, or vice versa. You can get input from the user via console, then save it to the file. So it can also go in the opposite direction. So you can start from here, it goes into the file. So yeah, and another way to view file stream, right? I like to use that example a lot with my students, com sci students. File stream, the way I've seen it, after all the experience I have with different programming languages, file stream is like Bluetooth. I agree, if me and you, we are sitting next to each other and we want to exchange files or information.
Yeah.
Let's say images, right, or files. Let's not involve data too much because data it won't allow me to explain this concept better than Bluetooth. So
Mm.
me and you want to exchange images, right? Let's say can be whatever scenario. I was graduating, you had an iPhone, and you took me pictures. Then I say, can you send me those pictures? Then I
Yeah.
say, send them via Bluetooth. Remember, we need to do what we call the first step in sending. We do what we call establish a connection, right? So we connect to each other, right?
Mm.
And so another word that you might be familiar with is called pairing. We pair, right? To I send a request to you to say I want to connect to you via Bluetooth, and then it does a pop-up message that do you want to pair or do you want to connect with the specific device? Then I'll confirm with you that this is my device, so yes. And then you say yes on your phone. Then we've established the connection. So file stream is literally that process. It's the process of connecting. So in order for you to send the file, you need to connect first. So file stream is like that. It's like us connecting to the file. So this could be you or me. This also could be you or me. We've connected to each other, right, via Bluetooth. In this case, it's via file stream because I don't know, maybe I might let me try to explain why they would call it file stream. Like for example, if you think of like a stream of water, right? I get the stream of water. You can, but then in this case, you have a stream of file, right? In some way, it's similar to that. So we just need to establish the connection first to the file, then we read from the file, and we establish the connection through file stream. And then once we are done, remember, once you're done sending the file to me, don't we disconnect? Don't you switch off your Bluetooth? You do, right? So once we are done working with the file, we're gonna need to, there's a function called close, which simply cuts the connection. We disconnect,
Mm.
right? That's all there is to it. That's all the file stream is for. It's meant to establish a connection to the file. Then how can we read and write to the file? Since you guys are being taught binary files, not text files, I don't know, but I didn't see text files. So since you guys are being taught binary files, that means okay, it'll take quite a lot to explain, a lot of time to explain, but I'm not gonna get into the nitty and gritty. But there's two types of files that you can save. It can be in text file, meaning when you open the file, it reads like this, right? It's in English. Or it can be a binary file, meaning it's in the language of the computer, called binary.
Yeah.
So
You
uh,
said
the,
file is it's an English form. Binary is the computer language.
yeah, it's the home language of the computer, the native language of the computer. It's called binary. So
Mm-hmm.
this is the language of the computer, you see. Very
Mm.
complex.
True.
So you see, it's very complicated. It might all of this is quite a lot. I don't like that's why they created programming language at the Visual Basic. Look at how many lines, 1,000.
You typed this.
No, I didn't type it. It generates it for you. Remember, when you compile,
Mm.
the whole process of compiling, right? It's
Mm.
translating from Visual Basic to the language of the computer. The computer is very stubborn. It's like a Zulu driver, taxi driver. It's very stubborn. When you go there and you're like, Dumelang, hey, taxi, what, and then you say, them like, then they'll look at each other. They'll be like, wemchunu, yazi angimuzwa, uthini lo? Basically telling you that you need to speak in their
Bathi
language.
awunazi isiZulu ongasisebenzisi.
Yeah, or you must find a friend who can speak Zulu. So computers literally like that. You can't communicate with it unless communicate with it in its home language. Since that's quite complex, people like you and me who are programmers, right? They
Yeah.
created what we call programming languages. So it's in between the language of the computer and English because we can't use English because English is ambiguous. You can there's figurative, all those things, figurative speech, what all those things, like there's sayings too, right? Like for example, you can say yeah, that killed me to death. But I'm not being literal. It's not saying like I literally died. But a computer might interpret that as, oh, you literally died. So let me confirm your reality. Let me take out a gun and shoot you. So that's how dangerous it is to have a language that's very ambiguous. So they came up with a language that's very direct. It's not like English. You can't have one word that has multiple meanings. One word means one, that one word means that exact one thing. It doesn't mean anything else. So that's why they came with languages like Visual Basic. You might be like, why didn't they use the language of the computer? You see how difficult it is. Look at all those lines. And imagine that all those lines just simply represent this. So yeah, it's really not a nice thing. So that's why they had to come up with a plan. So you guys will be learning how to write the file in its home language, is this syntax like this. But you don't do that. Visual Basic does that for you. You're gonna use what I call, since remember, um, um, yeah, remember we are writing in the language of the computer, which is binary, right? We are writing in the language of the computer. And I want you to pay attention to the terminology, the words I used. I said writing. So obviously, if I'm writing binary, I want to write in the binary language. We need something that we call a binary writer and a binary reader when we are reading binary. In this case, we are writing binary to a file. So we need a binary writer. If you are reading binary from a file, basically reading this binary file like this, we need a binary reader. I hope this makes sense. Are we still on the same page?
Yeah.
So yeah, let's see. Let's discuss this thing. So let's start with the file stream. So you're gonna need to create a variable of type file stream, right? I'm gonna call it fs for file stream, as file stream, right? And then we instantiate it. It's called instantiating, right? Which simply means you're creating, in other words, this would refer to this as like creating an instance of a specific thing. But you guys are not going to be taught instances and things like that. That's for first year majors of Com Sci. Well, those ones that do Informatics 1A and Informatics 1B. They learn all these things. They learn that this is what they call a class, and the class is simply an advanced record structure. So they end up teaching those things. By advanced record structure, right? I mean, it also has what you call functions. So you can actually literally define functions in a record structure in a way, but you don't actually say struct, right? You don't say structure. You now say class, but it's still like a record structure. But that's too advanced for you guys. You're not gonna be taught that. I don't know why they don't teach you, but you actually use a class. It's kind of weird to me, but it is what it is. So fs is equals to, so you instantiate, right? So meaning you create um a specific, how do I put it? You create a specific in a way you can view it a class, right? Let me explain a little bit about a class. A class is like a blueprint, like a template. For example, architects, they write a blueprint of the thing that they want to build. So that's what we call a class. That's the blueprint, that's the plan. Then the actual house is what we call an instance, which is the actual manifestation of the plan in real life, right? So it's the physical thing. So same applies with file stream. So I need to create an instance of it. So the physical thing of a file stream. So you use the keyword new followed by the thing you're creating. So I'm creating a new file stream. If it was of type house, you'd say build me a new house, right? So it's really that straightforward. So file stream, and then it takes in three very important parameters. So it takes in the first thing, what we call location, comma, it takes in what we call the mode, comma, access, right? Um, file, the thing is, I keep forgetting the file mode and access. They kind of sound the same. I keep forgetting. We have open what mode? Um, so yeah, I would have to refer to the slides again because VPL doesn't autocomplete. Other IDEs, right? There's apps whereby you use to code, and those apps, if you don't have to remember the syntax. You just simply type a few words and then it auto completes. Unfortunately, VPL doesn't have that feature, so you need to actually have everything in your mind. So we have the location, which is a string, right? Which simply represents where the file is located, right? Hence, called location, where the file is located. So this is where you can say it's in the C drive. In the C drive, it's in the downloads folder. Then it's gonna be called this name. So you usually write it in full. Like you'd say it's in the C drive, right? And then you'd say maybe it's in the downloads folder, and then it's called, let's say, q5.txt. So this you'd actually have to write it in full. Like it's supposed to be in this folder, within that folder, and it's good. The last thing at the end is the name of that file. Sometimes, right, you don't have to always do this. Sometimes you can just simply omit all of this, and just only put in the name of the file. I think it creates it in the same location as where that .vb, in this case it's called program dot what, yeah, practical library.vb. I think it stores it in the same location as practical library.vb, wherever in which folder it's stored in, if you don't put in the location. And then that's what you call the location. And then the mode would be, yeah, the mode would be um like what mode, meaning do you want to, I think it's do you want to open it or something like that? I think it's open, and then access would be what do you want to do after opening it? Do you want to read? Do you want to write into the file? And then mode, we have open. Yeah, open. And then I think we have also create. Yeah, so I think these are the ones you'd use most of the time. So you have open, meaning you want to open a file. By open, right? Open means the file already exists. Whether it's empty or not, that doesn't matter, but it already exists. By already exists, it means that if I go to that location, let's say, for example, downloads, I should find q5.txt. So open works in that way. With create, and if it fails to find it, I think it throws an error. And then create, it's when you know for a fact the file is not there to begin with. So meaning if I go to that location, I will not find q5.txt. It won't be there. So that means I need to create the file. That's the mode, right? And then the access is after, oh, in terms of accessing the file, you want to access it to do what exactly? Oh, I want to access the file so that I can read it. I want to access the file so that I can write to the file. So that's what that means. Do you understand?
Yeah.
Any questions?
No.
Okay, so let's start. Let me explain. Yeah, location is not hard. You know, it's a string. What we need to focus more on is file mode. So the mode, right? It's actually a, just know that there's some type that's part of Visual Basic. To set the mode, you say file mode dot, then you either say open or dot create.
Okay.
Then same thing for file for access. You start with the word file. So file access dot, and then if you want to read the file, you say read. If you want to write to the file, you say write. And then that's pretty much it. And then after this, right, let's say you've instantiated, you've built a physical file stream, right? It now exists. We need to create what we call a binary reader or a binary writer. I think I think is I forget the syntax, but um fs dot binary reader. Oh yeah, I think binary writer, it's like this. You say you need to declare, you remember you need to declare variable type binary writer too. And then let's say I'm gonna call it BW for binary writer. And then you say new binary writer. And then here I think you need to pass in the file stream that you're writing to,
Hmm.
right? you need to specify that this binary writer will write to this file. Remember, the file stream is how we've established the connection to the file. So if we want to refer to the file in any ways, by any means, we refer to the file via this variable of type file stream. So if I want to write to the file, I need to pass or specify that this is the file I'm writing to, which is via the file stream. And then binary reader, I think it's like this. If I still remember, it's you say new. No, binary reader don't say. I think it don't say new. I think you say fs. The thing is, I forget these things. Let me quickly open the slides. Like I'm not. I don't have photographic memory, so I can't possibly remember everything. So let's see. And it's a small thing. Let me just double check. And it's quite a lot. Yeah. It doesn't end. This thing must. Yeah. Binary writer. Oh, they're both the same. Okay, that's fine. This is the reader. And then, oh, I almost forgot about seeking. It's fine. I'll leave it open because I can't possibly remember everything. But yeah, at least I can still remember most of the stuff. Especially if you understand this first two parts about setting up everything. And don't forget to, at the end of the day, once you're done, don't forget to close.
Yeah.
By typing fs to close, it cuts the connection, but I want you to view it in this way. It's like literally after you've opened the file, oh, I've read it, oh, it is none, null, sol, whatever, and then I can press X to close the file, right? So that's what that does. It literally closes the file because we're done using it. So yeah, so that fs dot close it has to it is to close the connection to the file, which in turn just simply closes the file because we are done reading or writing to it, right?
Mm.
And then we need file when you're saving into a file, right? So let me make another diagram. Okay, let me quickly check something here. Um, um, yeah, just give me a second, check something here. Okay, so let's continue. So where were we? Yeah, so this you might ask yourself, what's the whole point of using the seek function and all that? Well, the reason you do that is that you can imagine a file is like there's no order in a file, right? Meaning things are not saved in order. We need to define our own order, whether that's sequentially, that's one of them, meaning in sequential order, like in a queue, one after the other. So if you look at your slides, right, they did explain this. So you can have, remember, we're gonna create a record structure. So we call them records. So you can have, let's say record one over here, right? And then there we go. And then you're gonna have, if it's sequential, it'll be one after the other. Then after this, you'd have record two. And then after that, you'd have record three and so forth, right? Because it's in sequential order. And then there's a second way, which is random, meaning we can randomly put one there, maybe this one here, and then three is here, right? So there's no order, right? As you can see, we define our own order. So since there's no specific order, we always need to do what we call seek. If you remember hide and seek, you can think of these records, this information as like hidden in a way, so we need to seek it. So how might we do that? That's the tricky part. So the easiest way to achieve this is to know the size of each record in terms of what we call bytes. So this would be, let's say in total bytes, it's 53, right? So it would know that 53 would each of these things is of size 53. And now it can tell them apart and know when to start reading the first information and when the first information stops. So this size, giving each record a specific size, it allows the computer to distinguish where each record starts and each record ends, so that it doesn't mistakenly read record 3, for example, right? And it doesn't reach the end. Think of it as like it doesn't reach this corner here. It doesn't stop there. It still continues and ends up reading record 1, and then still continues reading and reading and reading. That's 2 records. You can't read 2 records into 1 record. So we need us to give each record a size. And how do we determine the size? By looking at the bytes, because each data type has a specific number of bytes. If you look at you might ask, what are these bytes? These bytes are, you see, they're what makes up kilobytes, megabytes. They eventually get to this. That's what we call bytes. So I won't go into too much detail on that, but just if you would know, it's like kilobytes, and then you eventually get to megabytes, gigabyte, terabyte, and all the stuff. But it starts as 1 byte. So yeah, so that's we always need to seek, and we can use yeah, and we can even though we know the size, we can also use something that's unique. For example, like an ID number, right? Each record is a unique identifier, like an ID number or a student number that uniquely identifies that specific record. Then that record, we use that person's ID number as like a value to index, right? Like arrays. Remember arrays we use in numbers to index, like position 0, 1, 2, and so forth. You can think of like the ideas like that, like an index. But then the index is used in conjunction with the size of the record. So you say that I'm looking for this person with the ID number, and then you multiply by the record 53. This will help you locate that record you're looking for. That's the simple formula. Are we on the same page? Are you still breathing?
Yeah.
I thought I'd lost you for a second.
No.
So let's start answering it. Let's attempt to answer it. Let's see. So yeah, that's pretty much all you need to know. And you need to seek into the file to find it. And you specify what you call a seek origin, meaning where do you start from? You just simply say you're starting from the beginning. Simple, right? You need to start from the beginning. Obviously, if, for example, let's say you're in a queue, right, to go to a bank, and then they want to select people who are there to specifically, let's say, for example, maybe there's a booking system. Then they say, no, they want the ones that they've booked. I agree, when they're looking for the ones they've booked, they'll start at the beginning of the queue. They'll ask, did you book? And then the person says no. Then they move on to the next one. Did you book? Next one, did you book? And so forth. But in this case, we're no longer asking, did you book? We're asking, are you the student that I'm looking for? If you're not, I move on to the next person in the queue. Then I ask, are you the student? Are you the student? That's pretty much it. Yeah. And if you don't understand the reason why we need a size for each, if it's 42 each, right? That would mean that 42, and then after this would be like, for example, 84. In a way, I don't know if this will make sense, but if if it's all if they're all if they're all of size 42, the computer can know which one starts where and which one ends where. So for example, this first one will start at 0. I remember the things, let's view it in terms of arrays. If it's 42, that means it starts from 0 to 41, right? So the computer would know that, oh, I stop at exactly number 41. But then starting from the number 42 up to, I think it should be 82, 42 up to 82, that's the second record. So that's why the size is important. It needs to know when to start, when that record starts and where it ends, so that it doesn't mistakenly read other records. It only reads one record at a time. We need to tell it what's the size of each record, so that we can help it distinguish, tell them apart. So
Ngalo ngicela urepeat la code yakho number 25 ngicela uqale phansi angizwanga.
Number what?
Yeah, that line.
No, number 25. Oh,
Mhm.
the reason why we give each record a size, remember there's no order in binary files. So we need
Yeah.
to create somewhat of an order. There's two ways you can do that. There's two approaches. You can do it sequentially, like in a queue at the bank. In a queue, you need to tell when one thing starts and where one thing stops.
Mm.
For example, you need to know, oh, this is the first person. So the first person starts here and the first person ends here. In this
Mm.
case, in a queue, right? When you're in a queue, I get there's spaces in between people, right?
Yeah.
There's spaces in between you guys. Those spaces in between you guys, you can view them as like this space over here. So that allows the computer to tell them apart. Like, oh, this is the first record, then there's a space. Then there's the second record, then there's a space. But then in order for it to determine that space, you need to tell it what's the size of each of the things in the queue. So
Mm.
in this case, I used 42. Because let's say it's 42 bytes. So if it's 42 bytes, that means the first record will start at 0 up to 41.
Mm.
Then it puts a space. Then
Mm.
from 42 going upwards, we have a new record, totally different record. So that's how it will be able to tell them apart like this, and it will know, oh, this is record one, this is record two. So it doesn't mix them apart because it knows each record is of size 42. You might ask,
Mm.
why did I do this? Why did I say 42, 84? Because if you remember in maths, if you find the difference here, the common difference is 42.
Yeah.
So the difference is 42. So that's how it tells them apart that, oh, this is size 42. So that means if I have another 42, that means it's a new record. And if I have another 42, that, oh, it's a new record. So it helps it to tell to be able to distinguish them apart. Do you understand?
Yeah.
Okay, so let's start with the question paper. So yeah, I just think I hope that ganja shop doesn't close. The program given below makes use of the food record structure from the previous question. You don't need to redefine it. The program then uses. Oh, so we're using a record structure from the previous question. This is annoying. So I need to go back to that record structure. I need to find out what information it had. Question four, right? Yeah, so there's the structure. So I'm gonna say question four, open, and then question five, I'm gonna open it. Yeah. So I don't need to redefine it, but I just need to see it in when I'm gonna start calculating stuff. Yeah, because remember, you need to find the total number of bytes. So obviously, you need to look at the data type of each variable in the record structure. So that's why I need to know that information. So let's see. So I'm gonna go here. So let me do this. You had already defined the function. So what I'm going to do is I'm gonna remove this. I'll leave the functions, but I'll remove the code inside of them. And then let's see. Hmm. Yeah. So the program given below makes use of the food record structure. So we're dealing with food here. You do not need to redefine it. So it means don't need to create it again. The program then uses the make file and show food subroutines. They're very bad at English, these people. Because they're saying subroutines, but in the following question, they say, no, this one is a function. What do you mean? Why would you say subroutines then? Hey, these people just want to throw you off, which are defined in a hidden library to display the food record. The subroutine, and they're still saying subroutine, will create a file of records and then output each attribute in the record. You do not need to write the subroutine. You only need to define the functions. Make file show. Oh, these are defined some way. And then this is functions that we must create in this question. Oh, they can be very misleading, these people. So the module must contain the following. Read first food from file. You must define this function. It takes in a file name, which is a string, representing the name of the file of records. The function reads the first record from the file and returns it. Yeah, they said you read the first record, but hmm, yeah, I get that we read the first record, but hey, it's not making sense because remember how these records are saved in the file. They're saved using an ID. So I don't know what they mean when they say read the first record when you see that you need an ID, say student ID.
Mm.
Yeah, you need an ID. So we need to know what's the ID of the thing we're trying to look for. Because remember, they all have unique ID numbers. It's like searching in a database when you go to Home Affairs and they search for you. I they're gonna ask you your ID number because
Yeah.
that uniquely identifies you, so they can be able to locate you. In this question, they didn't tell us what ID. They're supposed to say this function is supposed to take in the ID of the thing we're trying to look for. Yeah, this is a very weird way of asking this question. Was yours running? Did you agree? You wrote code. Yeah, but I say zero here. I assume it wasn't working. I assume it wasn't working. Um, are you not supposed to say end module somewhere? Are you not supposed to have like an end module here?
Yeah, it showed.
Yeah.
I never done that question. Ngibeka ngikophisile.
Yo, and copy Bagit. You must do it on your own. Be brave, be bold. Show them that you have.
Ngicela uye phezulu nyana ngifuna ukubona lento ijunini lawo mock test.
Mm,
Abhala
Babalang, I think submission it just shows what you've submitted. No, I think these mock tests are just for practice. Because they have not due dates.
Mhm.
Yeah, it's
There
just for
were
you. It's just for you
there
to
were
help you
okay,
prepare for the semester test.
there were due dates. Bavulele thina bama-sick test.
Oh, so that means it is actually closed.
Mm.
Yeah, so yeah, I guess you must also attempt and submit since it's open for you.
Mm.
So we text in the file name. Let's look at the function. Yeah, this is the file name, and it returns the food that we've read from the file. So the record structure, did you call it food? I'm assuming you did question for. Yeah, so there's the structure. Yeah, here you're supposed to have VB fixed string
Ah,
like this, and then I think they said 20, né? They did tell you in the question though. If you read, they said the maximum. Mm, let me save. Let me go here. Yeah, must have a fixed length of 20 characters. So you must tell Visual Basic that it's fixed. Sort of like an array. Remember, string is like an array. So it's like you're giving it an array size in a way. Because if you leave it like that, it can be of any size, of which that's not very good in the long run because we're not gonna know what the size of each record is. Because remember, they need to be of the same size. Imagine if the first record was 41 bytes, the second one was 99 bytes. So it becomes very hard to locate. They need to be all the same size. So that's why they use VB fixed string. to make sure that they're all the same. They're all of a consistent size. Yeah, they remember they said it's a fixed length, meaning that's the maximum. That means you can have a string that's less than 20 characters, but the maximum is 20. You can't go beyond that. So yeah, that's what was missing. I think it didn't complain, but that's what's missing.
Thina abashayo ukuthi siyenze kanjalo shem.
Um, no, I think it needs to come before the data type. Né? Yeah, I think it's before the data type, the dim. If it was in primary, whatever. Ah, uthole zero, uthole kungu. You know, kids
I mean,
will bully you. They'll be like, "Hey, you got zero."
yeah, futhi.
Yeah, you see, you still get this. I guess they were kind of lenient in that question because it's supposed to say no, zero. Me, I'll tell you zero. You need to use VB fixed length. Yeah, we're building software engineers, even though you are accountants, but you are building software engineers.
Hey,
So that's the string. Then let's declare, right? So I'm gonna say dim fs file stream, right? As file stream. You can, it's up to you, right? You can initialize immediately after declaring it. That's up to you. Or you can do it in a separate line. That's totally up to you. Dim, so we are reading. So BR, binary reader. Or it's up. You can call it by reader, whatever whatever you want to call it. But usually they just abbreviate and say BR to save
Thando,
time. Yeah, bo.
ngisacela i-break e-5 minutes. Yeah.
Only break is too much info. But
Is it
we can, I think it's cool. We can, because I'm thinking about it like been covering a lot. You can take a break now, then we have a session maybe after 2 hours or so.
no, big 5 minutes right. Phela after mangiqeda nami ngisho kumele ngizipracticele mina ngiloko ngiyenza lama-questions.
Oh,
Ngifuna
okay.
ukuyenza something. Yeah,
Let's take a 5 minutes break then.
please. Yes.
Ngifuna ukwenza something. Basically means ngifuna ukuya toilet. Hayi, kumele usho ukuthi
wrong, Mohammed? What's wrong, Mohammed? Yes, that's me. What's wrong, man? Need to do that. I'm here. I'm not going anywhere. I'm here. I'm here. What's wrong? I'm here, man. Hey, I fucking don't can't get a break for 1 minute, eh? 1 minute, I can't get a fucking break, eh? Fuck off, sleep. This fucking guy who's on the ball, he doesn't go play in the back. I take his fucking ball and go play in the back. Papa, hey, you papa.
You're real sweet now.
I come back.
Are you back?
Yeah, bothi kusofuna ukulala.
I wanted to sleep.
Wena ngizokhuluma ngakusleep.
Nah, just tweaking. Yeah, let's see. So yeah, we're declaring the variables, right? So now we're going to instantiate them. How did you change the font here?
Hello?
How did you change the font?
The ukhuluma nami?
The color. Yeah, what we call.
I changed it.
Why does it? It's supposed to be black and white, but I'm seeing a red. I'm seeing this weird color. Hey, guys are busy doing spiritual things with VPL. So let's create it. So fs is equals to new file stream, right?
Yeah.
Easy peasy lemon squeezy. So str file name, because that's the name of the file. So I don't have to actually put in a literal string because we were told what's the name of the file. So I don't have to do that. So I just pass in that string. And then I specify the file mode. So file mode, I'm assuming you must read, right? So you're opening it because you can't read a file that's not there, right? So the assumption is that the file exists. So I'm gonna say file mode dot open, and then file access. What do I want to do with it after I've opened it? I want to read from it. So file access dot read because I want to read from the file. Since I want to read from the file, I need to use what we call a binary reader. So I need to initialize the binary reader is equals to new binary reader, which takes in the thing you want to read. I want to read a file which is linked to my file stream. So I'm gonna pass in the file stream object there. Then at the end of the day, don't forget to close the connection to the file. So file stream dot close. Don't forget that that goes down there at the end. Then now we need to write to the file, right? But before we write to the, let me see. No, we are reading, my bad. But then even if we are reading, we need to know the student number of the record you're trying to read. Here they just said you read the first one.
I
And I
mean,
don't know, and I don't know what do they mean by that. So let's see, let's look at the slides and see. But here they're using an ID, so I don't know. You see, you suppose I don't. That's why I'm not getting it because you're supposed to get an ID somewhere. So you see that ID, you use it to seek and look for that record. But then here it's not. You see, yeah, it's a problem. So I don't know how they want us to handle that. And since this function is supposed to return a food, so we declare a food variable. So what am I gonna call it? I'm gonna call it. Hey, what are we? Let me see if I can. Practical library. Um, but I'm gonna call it rec food. Rec food as food. right? And then it depends on how you've declared it in the previous question. I guess we have to go back to the previous question and check on that. Yeah, we have to revisit the previous question because I need to check how you declared the variables inside the record structure. And then what do we have here? Instantiate them. Then after instantiating them, we have this, right? The question is the ID. That's my main concern. Well, because they didn't specify here. The function reads the first record from the file and returns it. How do you read the first record when you don't know like the ID to use to seek with? This is what baffles me a lot here. Yeah, see, there's the rec food there, right? Mm, then read from the file, then calculate average, blah blah. Yeah. You must not write program at PP. It automatically be created. Okay. They're not talking about anything about the ID. That's my main concern. Or if I just pass in an ID that does not exist, it will read the first one. I don't know. So let's do that. But it makes no sense, Shem. So let's just create an ID that's empty. So as integer, right? But then I don't need to declare it because remember it's part of the record structure. So I'll just use the ID from this record structure. So I need to see what you've called it. So I need to open question 4 and open your code. So edit. Yeah, you've called it just ID. So I'm going to seek, right? So if let me see. Oh, I see it now in a way, but makes no sense. But I think I see it. You see here, right? Here we were reading a specific record. I think if you want to read the first record, right, you just simply remove line 3 and 4 because we're not given an ID number or an ID to look for. So we're just reading the first thing we find. So I think we just go straight to this part over here and we just start reading. So I'm just going to do that. So read from the file. Hopefully this works. So recfood.id is equals to br dot read an integer 32 bits. Yeah, you always use this function to read an integer. You use 32. There's also 64, but you're gonna use 32. It's most probably gonna be 32 bits. So we have that, and then we have the name. So rec
Hey, you said ngisuke ngifundani? Ngisuke ngireada ini?
integer, and it's of size. In a computer, right? You can store integer, the same integer variable, but it differs in the size, meaning the range of numbers it can represent. 32 bits, it can represent up to 2 billion, right? Maximum. Minimum is minus 2 billion. Maximum is 2 billion, around 2 billion, or roughly 2 billion. Then 64 bits, it's how much is 64 bits? If I'm not mistaken, it's like 9 quintillion somewhere. It's a very, very big number. So we're most probably not gonna use that. That's too big because it's an ID number or it's an ID for something. You're not gonna use a very large number. If you use there's 32 and 64. And this 32 and 64, it depends on your laptop. Let me show you. If you open your computer and you search about your PC, it will tell you whether your laptop is a 64 or 32 bit. So mine is 64 as stated here. You see, mine is 64 4-bit. So data types, the way they're declared, right? They're declared based on the maximum bit your operating system can handle. Some operating system is 32 bit, some is 64. But here we're just going to use 32 because the smallest one, and it's not the smallest one, but it's better. It's not too big, it's not too small, right? Dot name, so this should be read string. I think I'm not sure if that function. The thing is, I'm also used to other programming languages. So, and this thing is no autocomplete, so it's a problem, but it's fine. We'll work with what we have. And then we have calories, which is an integer. So rec food dot calories is equals to br dot read int 32 again. And then what do we have here? Num prices. I think num prices is used in the array, right? Right, Mtandus.
Yes.
Yeah, so I'll use that for this. So yeah, we need to resize. Yeah, programming is kind of tricky. Remember, this is just a variable that's empty. This record is empty. So I still need to redeem. So I need to redeem or resize. It's called redimension array, which basically means to give it a size. And we have the size, it's num prices. So I'm gonna say redeem rec food dot you said price history, right? What is it called? Price history array, price history, and the size is num prices. So rec food dot num prices. Are we still on the same page?
I'm not sure.
I'm simply resizing the array. Remember, you can just simply remove this, right? It still behaves the exact same way. The only difference is that all of these things I'm getting from the record structure. So I always have to say rec food dot. But it's still the same thing as resizing an array.
Mm.
So the only thing that's added is the rec food dot. That's the only thing that's new. The rest is familiar, right?
Mm.
Yeah. So I'm just simply giving the array a size. That's all. Then now, since I know the size, now I go through all we call them indices, right? Or indexes, whatever tickles your fancy, whatever way you want to pronounce it. But these are positions in the array. So I'm gonna say for the price, so I'm gonna use P for price as integer is equals to 1 to num prices. But remember, num prices is part of a record structure. So I need to always specify a rec food dot. So rec food dot num prices. And then next P. And then I'm gonna say what else? Yeah. So now I need to read the numbers into the array. So I'm gonna so remember instead you could read from the console. I could simply say cint console.readline and then you store it into the array at that position. But then now we're not reading it from the array, we're reading it from the file. So I'm gonna say recfood.price history at position P, right? And then I'm gonna say is equals to, instead of cint console.readline, I'm reading it from the file. So binary reader br dot read. What type is the array? It's type double. So I'm gonna read doubles. So read double like this. And then it's done. You're done reading. After closing, don't forget to return the record. So return rec food, and then you're done reading from the file. I'm assuming this is the order in the file. That's all I'm assuming. Hopefully it works because it didn't tell us the order, so it's like a trial and error thing. And then we take in rec food as this, and then we're calculating what average, right? The function calculates the average price for the prices, the array, and returns it. So we're just simply calculating average. But I need two variables. I need total. And remember, all the things in the array are double, right? So the total, obviously, the things that are they're gonna add up to a double. So 0.0 and then average is double is equals to 0.0 again. Then don't forget to return the average because this function calculates an average. And then in between here, I'm going to go through all the prices, right? And calculate a sum because I need to go through all the values in the array. Then I'm going to say for P as integer is equals to 1 to num prices. I remember it's of size num prices, but it's part of the record structure. In this case, it's referred to rec food. So I'm going to say rec food dot num prices, and then I'm going to say next P, then total. So total is equals to total plus the actual number, right? I guess that's how you get a sum. But then I'm going to abbreviate it to just plus or equals to. I don't want to type total again on the right-hand side of the equal sign. So total is plus or equals to, what's the value? It's inside rec food dot price is his story at index P. Then once we are done, this will add up all the elements in the array. Then once we're done, we calculate the average. And then we store it in the variable for average. So average is equals to total divided by the number of things in the array, which is number of prices. So num prices. But num prices is part of a record structure. So I'm going to have to say rec food dot num prices. So rec food dot num prices, right? Then, yeah, that's pretty much the average. So let's test it out now and see. So I'm going to save, and then let's see if it did pass or we're missing something. I'm not sure about but I think reading the first record, yeah, it's correct. But then this is kind it's weird because they'll tell you in the question paper that you read the first record, but they didn't teach you in the slides how to read the first record, which kind of not makes sense to me.
Yeah,
Why are you saying you?
it's a lot.
Yeah,
Like the question, like it looks like it's very different from la amanye ama-question. Ngathi ngifunda into entsha manje.
yeah. Hey, so I'd advise you go back and watch the recording and process everything nicely. The questions are similar, right? The only thing
Yeah.
that changes is whether you're writing to the file or not.
Mm.
Yeah, don't worry. Get to my level where you write code and it passes on the first attempt.
Wednesday ngiyayigcina lento le. I just hope ngingala ukuthi nje ngiyiphase ngingabhali i-exam ngithole exemption. Anyeke ngiphinde ngizifake ey'ntweni zama-comp sci mina.
Yeah,